All right, guys, this is your Chapter 1 practice test. So, like I said in class, I'm just going to run through all the problems. We've got 1 through 25, this whole page, so feel free to pause, rewind, skip ahead, whatever. So starting with number 1, this is an evaluation problem. So here is the original, and then they give us our values of x equals 3 and y equals -1. Okay, so what you do for these, they give you these values, you take them, you plug them in. So everywhere you see an x, you're going to plug in the 3, right here and right here. Every time you see the y, you're going to plug in the -1. So let's rewrite this just with the numbers plugged in. Anytime you plug something into an exponent, you're going to want to put parentheses around it. And then 2 plus 3 for x. So follow the order of operations. First thing we're going to do is look inside any sets of parentheses. So we've got one right here. So this equals 3 plus -1 squared. And then inside the parentheses, 2 plus 3 is 5. So I evaluate that. Next thing in the order of operations is exponents, so I need to evaluate this exponent right here. So that will equal 3 plus, and then -1 squared. When I take a -1 and square it, it comes out positive. So that's going to be a +1, and then times 5. So the implied operation here, when I have 1 and then a 5 in parentheses, that's implied multiplication. So the next thing I do is the multiplication. So 3 plus, and then 1 times 5, of course, is just 5. And then finally, I add those two numbers together. 3 plus 5 gives me 8, and that is your final answer. Okay, next, number 2. We want to simplify the following expression. So we've got -4, and then in parentheses, 3a plus b minus 2 times a minus 5b. So the first thing we're going to do is we are going to distribute the -4 to the stuff inside the parentheses. We're going to distribute the -2 to the stuff inside the parentheses. So be super careful here, because when you distribute negatives, you've got to make sure that you distribute the negative to both of the pieces inside the parentheses. So -4 times 3a, that gives us a -12a. -4 times b gives us a -4b. Then next we distribute the -2. So -2 times a is a -2a. And then -2 times -5b is a +10b. Because remember, a negative times a negative always gives us a positive. So then next we're going to combine like terms. So I have -12 that I can combine with a -2a. -12 and -2 gives me a -14a. Then a -4b and a +10b. That leaves me with a +6b. So that would be my final answer there. Okay, number 3, we've got a multiple choice question here. This says if 3m plus 5 equals 23, what is the value of 2m minus 3? Okay, so what this one allows us to do is we solve for m. We solve that equation, we get the value of m. So let's start there. Subtract 5 from both sides, so 3m is then equal to 23 minus 5, which is 18. And then to get the m by itself, we can divide both sides by 3. So I end up with m equals 6. So that's the answer to this equation, but that's not the answer to the question, because there's still one more step that we need to do. So knowing now that m is 6, we want to know what is 2m minus 3. So we take this 6 and we plug it in for m, and then simplify down. So 2, and then plug in the 6, minus 3. So first we multiply the 2 times 6 together, and we get 12, and then you subtract 3. 12 minus 3 gives us an answer of 9, which on the multiple choice was letter B. Next, solve. So we've got this formula that we start off with. And it says they want us to solve for p. So what that means is that for our final answer, we want p equals, and then we want everything on that side of the equation. So right here, the p is being multiplied by an m squared. It's being multiplied by a 1/2. So we're going to divide both sides by 1/2 times m squared. Same thing on the left, 1/2 times m squared. So on the right, these things will cancel out. So now let's take a look at exactly what this left-hand side is doing. So we have r divided by 1/2 times m squared. Dividing by 1/2, this part's a little tricky, but dividing by 1/2 is the same as multiplying by 2. So instead of putting a 1/2 in the denominator, which we don't ever really want to have a fraction in the denominator, dividing by 1/2 is the same as multiplying by 2. So this is actually the same as having a 2 in the numerator. So instead of taking r and dividing it by 1/2, we're taking r and we're multiplying it by 2, which is exactly the same. So this says that p is equal to 2 times r divided by m squared. So these two equations are exactly the same. the original one that I started with and this one. I just rearranged this one so that the P was first instead of the R. 5, we've got a couple of expressions that we're going to translate into math. These are our English to math translations. So this says twice the difference of a number and 11. So if we want twice the difference, we need to make sure that the difference is isolated. So the difference of a number and 11, we can write n minus 11, but we want to take twice that, which means after we find that difference, we want to multiply it by 2 on the outside. So that one, you got to be really careful that you actually do have the n minus 11. If we wanted it to be 2n minus 11, that would be the difference of twice a number and 11. But since you want twice the difference part needs to come first. It needs to come in parentheses like that. Do number 6 right here. The product of the square of a number and 5. Product means you're multiplying. So the square of a number would be the number squared. And then the product of that and 5 would be times 5. You never really see it like that, though. Usually when you're multiplying a constant, it looks like this, like 5n squared. So that would be your answer there. And remember, I'm using n. I just keep using n for number. It really doesn't matter. If you want to use like a q or a g or an s, it really doesn't matter at all. I just use n or x, whatever. 7, we are evaluating this absolute value expression. Looks like this. And then it says if y equals 2.5. So same thing as we did with number 1. We are going to replace this y right here and this y right here with a 2.5 and then simplify everything down. So 2, and then the first thing I do is I'm just literally replacing each y that I see with a 2.5. So when we talk about order of operations, remember that the absolute value symbol is also technically a grouping symbol. So I need to simplify everything in here first. So isolating myself to just this stuff, first I'm going to multiply the 3 times the 2.5, and 3 times 2.5 is 7.5. So start there. So 3 times 2.5 is 7.5, and then minus 8, still inside the absolute value, plus 2.5, which if I continue to simplify this up, when I do this subtraction, 7.5 minus 8, that ends up giving me a negative 0.5. Okay, then the next thing I'm going to do is I'm going to take this and simplify up the absolute value part. So remember the way that absolute value works? Even if you've got something that's negative inside the absolute value, it always comes out positive. So the absolute value of negative 0.5, that means we want to know how far negative 0.5 is away from 0. And its distance would just be a positive 0.5. So the absolute value of negative 0.5 is positive 0.5, and then I add 2.5. So back to the order of operations again. Remember, I multiply these two together first before I add. So 2 times 0.5, that's 2 times a half, and 2 times a half gives us 1, plus 2.5, and then finally we can add those together, and we get 3.5, and that is our final answer. Okay, solve and then graph on a number line. Let me flip for this one. Okay, so number 8. Okay, we've got negative 2b is greater than 18 minus b over 5. So this is just like your normal inequality. There's no absolute values on it yet. So we're trying to get the values of b by themselves on one side of the equation. We need to start with this 5 over here. It's really kind of messing us up. So we're going to multiply both sides by 5. So do the same to the left. The ones on the right will cancel out because I have one in the numerator and one in the denominator. 5 times negative 2b, that's a negative 10b. And this is greater than 18 minus b. In inequalities, I would always recommend getting your variable on the left. So let's move this b over here. If these cancel, I have a negative 9b is greater than 18. So I'm one step away from having the b by itself. So what I'm going to do is I'm going to divide both sides by negative 9. This is something that you need to watch out for. Please watch out for this. If you divide or multiply both sides of an inequality by a negative number, you have to flip the inequality. So these will cancel. All I have left is a b, but because I divided by a negative, the greater than symbol flips to a less than. And then 18 over negative 9 reduces down to negative 2. So that's my final inequality. We were also asked to graph the solution set on a number line. So we'll start, nice blank number line here. Here's 0, Negative 2 is my number of interest right here. Two things that you need to remember for a number line. Open or close circle, shading to the left or to the right. So here, because I just have a less than, I'm going to put an open circle. I don't have the or equal to, so the negative 2 is not actually included. And then this is a less than symbol, which means I shade off to the left. So I am shading everything over here to the left. And then that would be my final answer. Number 9. Carson has $35 to spend at the water park. The admission price is $25. Each soda is $2.50. Write an inequality to show how many sodas he can buy. So he's spending $25 no matter what. That's kind of like the flat rate fee. This is really similar to Rosa and her cell phone plan, if you guys remember that example. And then each soda is $2.50. So plus $2.50 per, let's do S for soda. And whatever money he's spending, he can't spend any more than $35. So we're going to say that whatever he spends has to be less than or equal to $35. If it's less than, that means he hasn't spent all his money. If it's equal to, that means he spends exactly the right amount of money. But of course, he can't spend more than the $35 he has because he doesn't have more than $35. So for number 9, all you were asked to do was write an inequality. We don't have to solve it. We don't have to graph it. So make sure you're looking at directions carefully. Number 10, we're going to solve this one. R minus 3 is less than negative 5, or 4R plus 1 is greater than 15. And again, just a reminder, that or does not mean that you get to choose which one you want to graph. This is an or compounds inequality. That's where you get the two pieces off to the side. So for this one, solve this piece by adding 3 to both sides. So first piece is R is less than negative 2, or whatever we get over here, start by subtracting 1. Remember, when we're solving equations or solving inequalities, we always add or subtract before we multiply or divide. So we've got a 4R left right here, divided by, is greater than 14, then divide by 4 on both sides. So we are left with R is greater than, remember I told you, if you do improper fractions, mixed fractions, decimals, doesn't bother me, whatever, it just needs to be a reduced fraction. So 14 over 4 reduces down to 7 over 2, or we could do 3.5, or 3.5, whatever you want. So let's put this together on an inequality. When you do the ors, what happens is you just combine everything up on one big equality. So here's the negative 2 for our first one. So R is less than a negative 2, which is actually the exact same thing we just graphed up above, but with a different variable. So we have an open circle in the negative 2, and we shade everything off to the left. And then here, 3.5. So we're looking at 1, 2, 3, 4. So we want to go halfway in between. It again is just a greater than, not a greater than or equal to. So I do my open circle, and then here I would shade everything off to the right. So remember those or graphs. They have the two pieces off to the side that look like oars on our rowboat. 11, solve. All right, here's our first absolute value inequality. So this one is a less than. So you've got the two different ways that these absolute value inequalities can be set up. They're extremely different, totally opposite from each other. So this one is a less than. Less than means we can go 11 units in either direction, but that's it. We want to be less than 11 units from 0. So we can go 11 units to the right, but no farther. We can go 11 units to the left, but no farther. So these ones get set up as a three-piece inequality. So we can go 11 units to the right, or we can go 11 units to the left. So negative 11 is the lower bound of our set. I can be anything in between, and positive 11 is the upper bound of our set. So when we're setting up these three-piece inequalities, the less than always turns into this. I take the stuff out of the absolute value and put it in the center. Then I put the positive version of this number right here, the negative version of this number right here. So I can go 11 units to the left or to the right, but that's it. Then when I'm solving this three-piece inequality, remember the way this works is whatever I do to the middle, I do to both sides. So my goal was to get this letter P in the center by itself. Got a 15 on the right. Got a negative 7 on the left. So that means any value of P between negative 7 and positive 15 would make this inequality true. So let's graph that. So here's 0. So we've got a whole bunch of marks in here. You guys know where this 15 is, somewhere around there. Whole bunch of marks here. The 7 would be somewhere there. Kind of space it appropriately. If you don't put every single value on there, at least